Good afternoon, students. Let me explain some more questions from exercise 4.2 properties of determinant. Now here the question number 6 is you have to prove that the value of this determinant is 0. Let us see how to do the question. Now let we suppose it is delta, given determinant is equal to delta. Now in the first step we are applying interchanging rows and columns because the value of determinant always remain the same when we are interchanging rows and columns. So again it will be delta. Now what? Interchanging rows and columns, we are getting this determinant. Now taking -1 common from each row, or you can say from each column. We are taking what? Here we are taking minus common from each column. Then it will be what? -1 raised to power 3. Now it becomes 0 minus a b a 0 c minus b minus c 0. The sign of each element of this determinant will be changed. Now simplifying it, we are getting here minus and this determinant, and this is again the given determinant delta. We can put it equal to minus delta. Now shifting this delta to the another side, it becomes 2 delta equal to 0. This implies delta equal to 0. This we have to prove in the question. The question is here we have to prove this is equal to 0. What we have done, we have supposed this is equal to delta. Then interchanging rows and column, we are getting this determinant. Then taking -1 common from each column, we are getting this, and this is again here the value of determinant given to us. Now we can put it equal to minus delta. Shifting it to the another side, we are getting here 2 delta 0. Therefore, delta equal to 0. Let us see another question. The question is given to this. We have to prove that this determinant equal to this. It means we have to factorize x minus y, y minus z, z minus x, and x into y plus y into z plus z into x. Now on the right hand, we have to simplify this determinant, get all these factors. Let us do how to do the question. Something we have to keep in mind how to start the question. When you will do the practice of these questions again and again, then the things will remain in your mind. Now here what we have done, we have multiplying the first row by x, second row by y, and third row by z. Multiplying r1 by x, r2 by y, and r3 by z. If we are multiplying each row by x, y, and z, if we are multiplying it, then we have to divide it also. Therefore, multiplying and dividing by x, y, z, we are getting in the first row x square, x cube, x, y, z, y square, y cube, x, y, z, z square, z cube, x, y, z. This we have done to make this column 1, 1, 1. When we take x, y, z common, now we can take x, y, z common from the C3. We are getting this. Then we left with what? X square, x cube 1, y square, y cube 1, z square, z cube 1. And this x, y, z will be cancelled out. Now yesterday I have told you when we are getting 1, 1, 1 in any row or column, the next operation we can know. Now here we are getting 1, 1, 1 in the column. It means we have to apply the operation in the rows. Now what operation we have to apply? Always we are applying the operation r1 to r1 minus r3 and r2 to r2 minus r3 to get the maximum number of zeros in any row or column. We are applying this operation. When you are applying this operation, r1 minus r3, it becomes x square minus z square, x cube minus z cube, 1 minus 1 equal to 0. Similarly, for the second row, applying what? r2 minus r3, y square minus z square, y cube minus z cube, again 1 minus 1 equal to 0. We are getting the maximum number of zeros in a particular row or column. Now here, before expanding, we will see that before expanding, let us see, taking x minus z and y minus z common from r1 and r2. We can easily take the common. Sorry. Now here we can make the factorization here. It is x square minus z square. We can make the factor x plus z into x minus z. Now x cube minus z cube can be written as x minus z into x square plus z square plus xz. Similarly, we can make the factor of the second row. Then we can take x minus z common from the first row and y minus z common from the second row. This we are doing in the next step. Taking x minus z and y minus z common from R1 and R2, we are getting here this expression x plus z, x square plus z square plus xz equal to 0. Similarly, for the second row and the third row, we have simplified our determinant. Now again, now two factors we are having x minus z, y minus z. Third factor we want x minus y. Again we can subtract R1 and R2 to get the value of what? X minus y. Now operating R1 to R1 minus R2, we are getting here x minus y. Simplifying these two, we are getting here x square minus y square plus z into x minus y. Again it will be 0. Second row and the third row will remain the same. Again we can take x minus y common from the first row. We are taking it common and simplify the remaining determinant. We are getting here 1. Here we are getting here x plus y plus z 0, and second row and the third row will remain the same. Now maximum we have simplified our determinant. Now we can expand it by what? We can expand it by C3. It should be here. We are expanding it, we can say by expanding it by C3. Just correct it. It should be C3. Now here expanding by C3, we are getting these factor as it is. Now 0 into something 0, then minus 0 into something 0, then 1 into, we are expanding 1, hiding this row and this column. We are getting here by cross multiplying x square plus z square plus yz minus this into this. Now we can simplify this expression. The common term will be cancelled out. Now here simplifying this, we are getting here minus xy plus yz plus zx. Now this minus sign can be adjusted here by putting it here, z minus x. This factor will remain as it is, and here we are getting our what? Right hand side. This we have to prove in our question. Have you seen it here? In generally, what we have to done? First we apply the operation to get some common term in any row or column. Then taking x, y, z common. Then applying the operation to get the factors given on the right hand side. And we have the maximum number of zeros. But if we are getting the maximum number of zeros, but our determinant can be simplified, then we have to simplify by taking the common terms, and then we are getting by simplifying and expanding by here should be C3. Simplifying, we are getting our right hand side. Now let us see the another question. Now the question is here, we have to prove this determinant equal to this. Now you have to just see the determinant to get what we have to do to get our right hand side. Now in the right hand side we have to given 5x plus 4 into 4 minus x square. Now clearly it is seen from the determinant. When we add all the columns or all the rows, we are getting the term 5x plus 4. So first operation we can apply operating R1 to R1 plus R2 plus R3, or we can operate C1 to C1 plus C2 plus C3. We are getting the same term 5x plus 4. You can do any operation here. Either you apply the operation in rows or you can apply the operation in column. Now operating R1 to R1 plus R2 plus R3, we are getting in the first row 5x plus 4. Again in here we are getting 5x plus 4. Again we are adding all these, we are getting 5x plus 4. And other rows will remain the same. Now taking 5x plus 4 common, we are getting 1 1 1 in the first row, and the second and third row will remain the same. Now we are having 1 1 1 in row. It means the next operation we have to apply in the column. Earlier I have told you what operation we have to apply here. We have to apply now the 1 1 1 is in the row. Then we should apply C1 to C1 minus C3 and C2 to C2 minus C3. Let us see here. Then operating C1 to C1 minus C3 and C2 minus C3, and then expanding it by R1, we get our right hand side. This is about this question. You can easily complete it. Now here the next question is here. We have to prove this equal to this. Now here left hand side we are having this determinant, and right hand side we are having only the factor a plus b plus c whole. So let us see. Firstly, we always try either by adding all the rows or all the column. Are we getting some factor given on the right hand side? Now here when I'm applying here R1 to R1 plus R2 plus R3. We are adding all these terms. We are getting what? A plus B plus C. Again we are getting here A plus B plus C. Again adding all these terms, we are getting A plus B plus C. Now first row will be this, second and third row will remain the same. Then again taking A plus B plus C common, we are getting again 1 1 1 1 in first row. Again what operation we know? Now it is 1 1 1 in the first row, and second and third row will remain the same. Now we are having 1 1 1 in a row. It means the operation should be applied in the column. Operation is same, C1 to C1 minus C3 and C2 to C2 minus C3. And then after applying, if we are having some common factor, then we can take it out and then we expand it by R1 to get our right hand side. In this way you can complete your question. I have given the whole solution. All the step I have told you what you have to do in the question. Now here, see the question this. The question is here, we have to prove that this determinant is equal to this. Now see in this question, it is very much clear from the determinant on the right hand side. When we are adding all the rows or all the columns, we are getting 1 plus x square or 1 plus x square plus x. So we can either add the rows or we can either add the columns. Then operating here, R1 to R1 plus R2 plus R3, we are getting this here. In the first row, we are getting element 1 plus x square, again 1 plus x square, again 1 plus x square. And moreover, one thing you should see, that 1 minus x cube can be written as 1 minus x into 1 plus x square. It means 1 plus x square is one of the factor of what? 1 minus x cube. Now here applying this operation, then taking 1 plus x square common, again we are getting 1 1 1 in the first row, second row and third row will remain the same. Then we can apply the operation what? C1 to C1 minus C3, again C2 to C2 minus C3, and then by applying this operation we are getting the maximum number of zeros in any row or column. Then we can expand it by this, and on the right hand side firstly we will get the expression 1 minus x into 1 plus x square whole square, and multiplying we are getting here 1 minus x cube whole square. And now you can complete this question. See it again. Main is here. It is very much clear from the determinant, either we can add the rows or we can add the columns. We are getting this factor either in the row or in the column, and this is one of the common factor of the given expression on the right hand side. Then we are getting 1 1 1. If getting 1 1 1 in the row, we have to apply the operation in the column, and then we can, by expanding or by simplifying, we are getting the value that is given on the right hand.